Hello and welcome to a new tutorial on measures of center and spread for our Bio170 class. I'm your instructor, Israel Del Toro, and today what I want to do is walk us through a little bit of the standard normal distribution and the associated measures of spread with the standard normal distribution, which include things like standard deviation, quantiles, standard error, and 95% confidence intervals. So let's start off by drawing a quick and basic standard normal curve. We know that our standard normal curve is a curve that has a mean of 0, and most of that data, it's also very symmetrical, and most of the data within this standard curve falls between 1, 2, and 3 standard deviations from the mean. We know that within 1 standard deviation from the mean, so this area right here would encompass about 68% of the data. Within 2 standard deviations of the mean, so that would be the area between here and here, we'd cover something like 95% of our data. And within 3 standard deviations of the mean, so that would be going all the way out here, we can encompass about 99% of our data. Great. So once we understand what the standard normal distribution is, we can try to start to understand what standard deviation is. And so to understand standard deviation, the first thing we want to do is figure out what the appropriate equation for this is. And so here it is. Our standard deviation is also often known as sigma. And here's my pencil. Sigma can be estimated or calculated as the square root of the sum of the differences of each observation minus the population mean squared all over n minus 1. The example that we used in class this week, let me see if I can get a new board here. This week in class, we had the example of looking at the populations of LDL cholesterol levels in 2 groups of individuals, a group of vegans and a group of omnivores. Our vegans had LDL levels of 75, 92, 94, 88, 86, and 103. If we were interested in calculating the standard deviation of these data values, or sigma again, we'd be looking at the differences of each one of these observations minus the population mean all over n minus 1. And so the first thing we might want to do here is just calculate our population mean, or our mu, or our x bar. Our population mean is calculated by taking the sum of all of these observations and dividing it by the number of observations. In this case, we have 6 observations. Our population mean in this case is going to be something close to 89.667. We also know our n, the number of observations, 6. Now, to calculate out sigma, all we have to do is take each one of these individual observations and subtract it from the mean, this guy, square it, sum it, and then divide by n minus 1. Ultimately, you'll take the square root of that whole thing, and you'll get our standard deviation. So let's walk through this process. Let's start off by calculating some differences. So 75 minus 89.667. We can also take 92 minus that same value, 94 minus that same value, 88 minus x bar, 86 minus x bar, and 103 minus x bar. All of these values are ultimately going to be squared. So we're going to end up with a positive value here. If we take all of these values and do the math here, we end up with a total of 214.91, 5.42, 18.749, 2.755, 13.39, and 177.6889. These are the values that we ultimately want to sum together. And so what we have here is now simply the sum of these values. So if we take all these values and added them all up, we would end up with 432.93. Great, so now we have the top part of our fraction here, which is 432.93. All we have to do now is divide it by n minus 1. So 432.93 over 6 minus 1, which is 5, is going to give us a total of, let's say, 86.586. The last step in calculating your standard deviation here is to simply take the square root of this value, and our sigma value then gives us a total of 9.305. Great, so now we have our standard deviation calculated for this particular population. What about standard error? We'll do that next. All right, let's go ahead and take a look at standard error next. We just calculated our standard deviation, or our sigma value, and we had a total sigma of 9.305. Standard error is going to be simply that sigma value over the square root of n. And so here, standard error is pretty easy to calculate. We're going to go SE is equal to 9.305 over the square root of 6, because we had 6 initial observations. If we do the math there, our standard error is approximately 3.79. Great, so this gives us our standard error. The next bit is going to be to take that standard error information and use it to calculate our 95% confidence interval. So our 95% CI. What do we mean by a 95% confidence interval? Well, let's plot out this distribution. Assuming that this distribution was fairly normal, we know that our mean is about 89.6, and we know that one standard deviation from the mean is going to be, so 1 sigma, is going to be 89.6 plus that 9.305 value. 2 sigmas, or 2 standard deviations, is going to be 89.6 plus 9.305 plus 9.305. Right? And so we remember when we said in our standard normal distribution that approximately 95% of our data would fall within about these 2 standard deviations from the mean? Well, that's how it's all coming back to calculating this 95% confidence interval. To calculate a 95% confidence interval, all we're going to do is take our population mean, so our x bar here, plus or minus 1.96 standard deviation, so close to that 2, not exactly that 2, but pretty close to it, times our standard error, which is 3.79. And so if we just fill in what we have here, we know this value to be 89.667 plus minus 1.96 standard deviations times 3.79. And so now we can just do our confidence limits, which means 89.667 plus 7.44 and minus 7.44. This is going to give us our upper range of our 95% confidence interval, and this was going to give us our lower range of our 95% confidence interval. So now all we do is take that 89, add that 7.4, and we end up with an upper range of 97.11 and a lower range of 82.23. So for the distribution of the LDL values of these vegans, we know that 95% of our observations, so the area shaded here in red, falls between a maximum value of 97.1 and a minimum value of 82.3. All right, so with all of this in mind, let's say we wanted to add a second group to compare. Now, instead of just looking at the data for vegans, we can compare this to the data for omnivores. That's you guys' homework for this week, and you guys have the problem from class, so give it a shot. Try it out and bring some of those notes to class, and we can talk about them all together. All right, see you guys next time.